This is a transmission. A box of gears that turns engine spin into the right speed and force for the moment. Why do we need such a machine? Let's see, with physics. To keep the engine in its efficient RPM, we insert a machine between engine and wheels that switches the gear ratio. Open it up. An input shaft and an output shaft. Between them, only one selected pair of gears is meshed at a time. Launch in first gear. The tooth count ratio is large. Output torque is multiplied many times, enough to move a heavy car from rest. In return, the road speed is low. You gain force, but you lose speed. Cruise in top gear. The ratio is small. One turn of the engine carries the car far down the road. Less torque, but you no longer need it. Efficient, high-speed cruising. The speed-force trade is set by the tooth count ratio alone. Output speed is the input divided by the ratio. Output torque is the input times the ratio. Speed times force stays constant. That is the trade-off, exactly. The dot on the right is the operating point, riding on the curve. A lower gear sits top left, low speed, high torque. A higher gear slides it down to the bottom right. Now let's accelerate. Launch in first. Shift up before the engine revs out. First, second, third, fourth, fifth. Lowering the ratio keeps the engine in its happy band while road speed keeps climbing. Finally, the final drive gears down once more and splits the drive to the wheels. One engine's power, redistributed from launch to cruise. That is the machine we call a transmission. NovaSolver. Physics made visible.